Hello, and welcome to the December 20th meeting for the Cluster API Working Group as part of SIG Cluster Lifecycle. Today, we are going to get started talking about the 2018 roadmap. So I've linked a doc that Lucas started putting together for the overall SIG Cluster Lifecycle roadmap for 2018 at the top of the meeting notes. And he has a section there for Cluster API where he took sort of a stab at what he thought we were working on, even though he doesn't come to this breakout meeting. So I can paste his thing into these meeting notes if people don't want to click through. And I'm curious what people think about this as sort of a goal for next year. If we think it's too ambitious, not ambitious enough, or if it's sort of the right direction to be headed in. It's sort of that time of year where we're trying to figure out what we're up to for the next large chunk of time.
Should go stable.
Do you think beta is not ambitious enough?
You have 4 releases, right? Well, we'll see.
You mean 4 releases of Kubernetes?
Yeah.
So we are not in the Kubernetes repo, so we are not tied to the Kubernetes release schedule.
Yeah,
so we can release,
potential for releases.
We can release as many times as we want. Not quite infinite, I don't think, but we can release many more than 4 times. I think Lucas might have put beta here as sort of a conservative estimate. I do think it would be great to try and have something that's GA by the end of the year. With beta, maybe sort of about halfway through the year would be ideal. So we'll just get rid of beta there.
I personally have a question about that. What makes an API beta?
Justin, are you raising your hand to answer that, Justin?
I do. You go first, and then I'll add on if I want to raise something.
Okay, I was going to try to pull up. There's a doc where we actually describe each of the API levels, alpha, beta, and GA, and what that means. The biggest thing that's different between alpha and beta, though, is once you hit beta, you can't have changes that are breaking that you can't upgrade. So there can be changes as long as you can automatically upgrade from the old version to the new version, whereas in alpha, you can have any breaking changes that you want.
And I think the important thing is that alpha, beta, stable does not imply anything about the quality of the actual thing. So something can be API stable, but not work at all. But as long as we're committed to not changing the API, that is considered acceptable. Kinda.
David found the link before I did. I'm going to paste that into the meeting notes. So if people haven't taken a look at that doc that was just linked, it does describe what happens at the alpha level, the beta level, and the stable level. There's not a whole lot of difference in the doc between beta and stable. Otherwise, other than the fact that we accept stable to be more stable, I guess, if you will, than beta. And typically things sit in beta for a release or 2 of Kubernetes, so 3 to 6 months, before being promoted to GA, so we can get some actual usage on them. But that's a good question, because I assume that a lot of other people on the call also don't necessarily understand the distinction.
Yeah, thank you for asking that. It's helpful for me.
So other than the specification, hopefully getting to GA, definitely to beta in 2018, Lucas had written down some implementations of the API that he'd like to see. So GCE, Terraform, I think I added Docker machine ? Because that's what the Luzi guys have been using for their product with node sets. He put kops, kubespray, and kubicorn support all with question marks at the end, and also using the cluster API for our end-to-end tests. So this is basically an intermediate step of replacing Kubernetes Anywhere and using that instead using a cluster API implementation instead. I think everybody had high hopes for Kubernetes Anywhere, and it's gotten parameterized to the point where it looks sort of like the kubeup scripts, which is unfortunate. And people that aren't sort of very deeply involved in it have trouble figuring out what it's doing. So hopefully we don't fall into that same trap a third time. I think, Justin, you guys have been able to avoid that on COPS. So
well, actually, Chris Nova has a very good talk about this, where we didn't avoid that. We actually made the same mistake where we started off with templating, and we ended up moving everything to Go code instead of using templating, because inevitably, like, templating devolves into exactly this. Everything is templated, and you're effectively writing code, and you move more logic into the back end, and it's just, you might as well just write it in Go. Or it works well to write it in Go.
Yeah, it is interesting because Kubernetes Anywhere is built on Terraform, at least on GCP. And one of the things we'd like to see in the cluster API is a Terraform implementation, so that you can use Terraform and have that sort of configurability. That also could potentially lead down that same road, right?
So, I mean, that would be a re-implementation, right? We actually looked at creating an API on top of Terraform, and it's just not written to be a library. I'm actually kind of skeptical of attempts to abstract cluster infrastructure the way Terraform does. I think that APIs are a more accurate and truer representation, and especially writing in Go code, it makes it easier to programmatically do things that you can't do with Terraform as it is. I mean, you get this semi-structured text back, and even a human can barely parse it, but a machine can't do much better.
Yeah, I think the appeal of having Terraform as an implementation is that you could take sort of the generic description of what a node should look like, and then dump in a Terraform blob. Because a lot of people are using Terraform today, and that provides both a migration path to the cluster API, but also it provides sort of very broad platform support with no extra work on our end, because Terraform itself has broad platform support, right? So you could imagine if we don't have, like, say, an Azure-specific controller for machines, you could still use the cluster API on Azure just by using Terraform, right? And it might not be quite as clean as an AWS or GCP implementation if we have specific controllers for those, but it would still work. Yeah, so I would imagine that, you know, the bigger use cases would have specific implementations, and then Terraform would be sort of like the lowest common denominator fallback.
I have a question. So what does it mean to have COPS and KubeSpray, Kubernetes support? Does that mean that those projects would adopt a cluster API, or that the cluster API would be somehow aware of what those projects do? What does that mean?
I'm happy to answer as to what the immediate plans are for COPS adoption, and like I think I have a pretty clear idea of what we should do in the short term, which is COPS currently creates, we have this notion of instance groups, which is like MachineSets. And what we will do is, and we currently map those to, on AWS, auto-scaling groups on GCE MIGs. We will map them, at least for the nodes, we will now create a cluster API machine set. And we will have a machine controller that will go and create those and install those nodes. So the COPS API will be we'll have a backend that is the machines API. And then, like, longer term plans are, adopt more of the cluster API, use the machines API for masters as well, and maybe port, once we're at parity, port the COPS instance group concept to be the same as the machine set, or whatever that concept is. But the short term plan is have it so that COPS, at least for the nodes, creates machine sets. So the masters are a trickier problem, but at least for the nodes, create machine sets and back it that way. If that makes sense.
Yeah, I guess the way I sort of see this going is, COPS has an API today that defines what a cluster should look like. And Kubernetes has an API today. I think it's starting to migrate already to the cluster API, but it has its own sort of API of how you define a cluster. And what I would hope to see is as we define these sort of common pieces. So we're talking about the machines API right now, but there's also the sort of cluster control plane-ish parts that we have to define as well, that those tools would start to use those as sort of their native API. And COPS might have some extra fields that it still needs to provide independent of those, or Kubernetes might as well, but that the common pieces are common, such that then you can write tooling like an upgrader, that if you installed a cluster with COPS or you've installed a cluster with Kubernetes, it doesn't matter. You can point your upgrader at either of those clusters, and it can use the machines API to upgrade all the nodes. So I guess that's what I think of when I think of support, is like if you provision a cluster with one of these tools, you can then use your cluster management tools after that to start managing the cluster lifecycle going forward.
Is this also the idea for Google Container Engine probably in the future, that they then completely use the cluster API so that I can completely manage my cluster over the cluster API?
Yeah, that's on my wish list, is to have GKE also support the cluster API, because I don't want to have a separate implementation. I don't want to have a separate set of tools that only work for GKE. And I talked to the CoreOS folks at KubeCon about this as well. And I think they're in a similar boat with Tectonic, where, like GKE, they have a lot of sort of custom code that is largely redundant with, other cluster provisioning and cluster management projects that are out there. And the more of that code that we can sort of share, and the more of the APIs that we can share, I think, each vendor is going to have a little bit of sort of secret sauce or special stuff that they want to add. But I'm hoping to reduce that as much as possible. Right now with GKE, we see that we have a pretty big maintenance burden of maintaining the GKE code, in addition to keeping up, with open source changes and trying to maintain the open source code. And we'd like to reduce that maintenance burden going forward.
Has there been any collaboration or discussion with the folks from the InfraKit project, people like David Chung, or any of the Docker core team? I'm sure that they would also have a platform interest, considering that their EE platform needs to support Kubernetes. I'm kind of hearing like a similar architecture, and it kind of makes me think of like a CRI, but instead of containers for nodes, or machines.
Yeah, I don't think anybody's talked to those folks yet. I think we've been trying to find as many people in the Kubernetes ecosystem that have been sort of walking down this road and trying to rope them in and get people on the same page. We have not yet looked as much outside of that ecosystem. So if you have any contacts there, that would be great to loop them in.
We had like 3 months or 4 months ago, first initial contact regarding the node set. Probably I can contact them again and say, hey, that's a new idea. So they were open to it, and but for us it was currently not so important to integrate with InfraKit. But when it's now getting bigger, I think probably they would be also interesting into it, how to integrate, and yeah.
Yeah, I mean, I could see a pretty clean like translation shim for a lot of the InfraKit objects directly into the cluster API schema. Where InfraKit potentially would still be managing the creation and lifecycle of the nodes, but then the cluster API controller could translate those objects into something that's stored in etcd.
Do you have any idea, Lee, how interested the Docker folks might be in collaborating on that? I mean, I think what we're designing right now, at least, is pretty Kubernetes specific, and maybe it makes sense to step back and think about it a little bit more generically, but maybe it doesn't, right? At some point, if it's too generic, it's not actually going to solve our problem in a reasonable amount of time.
Yeah, I think what we should build should be specific to Kubernetes nodes. And I think that the interest would only be in the frame of, well, Docker EE has to support Kubernetes nodes, and that they would probably entertain trying to expose that information in the Kubernetes way to a Kubernetes operator, a Docker EE operator. I can't speak for them though, obviously, but I can go ask the question.
That would be great. Do you know how they run those today? I mean, they have Docker Machine. I'm kind of assuming that they use Docker Machine to provision VMs for their testing.
No, it's a complete
InfraKit.
Sorry, continue.
Yeah, InfraKit has its own provider shim, and the providers tend to be implemented specifically for InfraKit. Some of the code gets forked from Docker Machine. They're also similar to what we were just talking about, is a shim or a provider for Terraform, which is maybe the less ideal way to do it, but also a really interesting kind of beast in its own right. But that's how they get the platform support.
Sebastian, did you have something to add on to that, or did that cover what you were going to say?
Yeah, it mostly covered it. But yeah, in general, when we talked to them, they were quite interesting in general, probably to support an idea like NodeSet. And yeah, I will drop them an email. So probably we can get some inputs from them. What's currently the status, because it's already 3-4 months or longer ago. So, I mean, now they also move more to Kubernetes. Probably also a lot of things change on their side.
Yeah, just in regards to NodeSet, a group is the kind of the primary scheduling object in InfraKit. So you have groups of instances, and then you flavor the instances. It's kind of the 3 top level objects. And the groups are declarative, like based off of kind of a replica count.
So to me, that sounds pretty similar to COPS. I was talking to Chris Love. He said COPS was not as interested in like the singleton machines and was more interested in the machine sets, and that's what they'd like to adopt, which I think is in line with what Justin said. And I think that's also what Eric Paris was saying last week, that Red Hat was more interested in, was that set concept as well. So I don't know. It looks like someone added a Kraken support ? Here. I think Lucas had just thrown out a couple of things that he sort of knew were entertaining the idea of potentially adopting the cluster API, which was COPS, KubeSpray, and Kubicorn. I would love to see broader tooling support. So I don't know who added Kraken or if they work on Kraken, but it would be great to loop those folks in as well. I know I talked to someone at KubeCon who was working on Kraken, and it sounded like that would be a good fit to sort of mesh with the cluster API.
So I added that, and the reason is right now I'm looking at the Kubicorn implementation of the AWS cluster API. I'm kind of curious where Justin is with COPS and implementing the cluster API, because I think what we would like to see, Samsung, we would either like to see Kraken become a very small shim, sort of like Kubicorn does now, and then use the cluster API to stand up the rest of the cluster. Or we would like to adopt potentially a different product like COPS or Kubicorn if all of our requirements are met. So we're still kind of evaluating whether or not we want to re-implement this, or if other people are actually doing it and we can just work with them. But there may be value in having an alternative implementation anyway. So.
I'm curious, when you guys started Kraken, did you sort of evaluate the other tools that are out there, and what things did they not support that led you to build a new tool?
Yes. I mean, so Kraken was originally started 3 years ago. And so the landscape was much different. Even today, some of the biggest things we struggle with, the biggest difference we have with most other tools has to do with our etcd configuration. I'm of two minds on this. There's half of me that says etcd absolutely has to be external to Kubernetes and isolated. So it just has to do with the design principle of not having any recursive dependencies. There's another part of me that says etcd is so hard to manage, you're crazy not to self-host it and use the operator. And then I think, well, if I wanted to meet both goals, maybe what you do is you have a self-hosted etcd in one Kubernetes cluster acting as the etcd for a different Kubernetes cluster, right? And that Kubernetes cluster can self-host an etcd for a different, so basically you can still self-host, but you're not self-hosting for yourself. At any rate, that's the biggest area of difference that I see between the different implementations at this point.
And is that just because the other tools are opinionated, saying etcd lives inside the cluster and don't give you like the out to move it out? Because I know that kubeadmin, when you're installing a kubeadmin cluster, if you go to that level of tooling, it allows you to specify an external etcd that's outside the cluster.
Right.
But it doesn't set that up for you, right? So does Kraken set up that etcd that's then outside of the cluster as part of its provisioning?
It does now, and I'm currently working on it. So right now, it sets it up as system units. And I'm actually chain commit to do static manifest. Once we have static manifest, I don't see any problem with self-hosting. And then the only question is whether or not we're comfortable self-hosting and having that internal dependency. And I think there's a way around it, like you said, using kubeadm and then pointing to an external etcd.
Okay. Are you guys running HA etcd? Okay. The CoreOS folks let us know at KubeCon that self-hosted HA etcd had some unfortunate edge cases. There were some bugs right now. So I would recommend not doing that yet until they sort of figure out how to make it work. Because they've been spending a lot of time trying to make that work for Tectonic, and have found some places where it doesn't quite work correctly. And it's difficult to recover from the failures.
So you're saying I shouldn't use static manifest?
No, static manifests are fine. They said static manifests are fine. HA etcd is fine. It's when you try to self-host HA etcd inside of a Kubernetes cluster that there are some edge cases where you have sort of really bad failure scenarios. And some of those are, they think.
It's interesting how the game of telephone works. Sorry, I was going to say, because I heard the same thing about self-hosted HA, but the way it was told to me is that HA in general didn't work.
That was not my understanding at all. I believe Tectonic runs HA etcd, and it's fine. I know we're running HA etcd in GKE now with regional clusters. I think COPS supports HA etcd as well, and has for quite a while. So I don't think like running multiple etcds in a cluster has problems. I think it's when you couple that with self-hosted that you can get cases where it fails. And they weren't specific about what those cases were. They just recommended against doing that for now.
I've also been working, like I obviously have the COPS thing.
Can anyone else hear Justin, or did he freeze for everybody?
No, my internet connection. I'll try one more time and then I'll be quiet if it doesn't work. I've been working on an etcd manager, which uses etcd instead of the Kubernetes API for self-hosting. So it's not self-hosted, but it's like a bootstrap thing that may be more reliable. It's on my GitHub. I'll paste a link in a minute when I find it. But if anyone is interested in collaborating or playing with that or whatever, then let me know. But it may be a nice bridge between static pods and the idea of the operator without introducing the circular dependency thing. And I'll put a link in the comments in a minute.
Right, because even if you do what David was suggesting of having a separate cluster using the etcd operator, managing etcd for your main cluster, that cluster itself has to have an etcd, and you still have, like, how do you put the turtle at the bottom, right? Well,
maybe GKE can put the turtle at the bottom, but yes.
Well, then we have to do something that's different from everybody else. I don't want to do something different from everyone else.
Well, the idea is that you would have each etcd running a different Kubernetes cluster, and they would manage the other Kubernetes cluster, right? And then you only upgrade one cluster at a time. When you do that, you don't have the circular dependency.
Interesting. So you wouldn't have sort of like a bootstrap cluster that just manage etcd for your primary cluster. It would be like literally you spin up two clusters and they can both run user workloads, and you would just sort of alternate upgrading them. Is that the
you may not run workloads on one of the clusters that's running etcd. You don't have to do that. The main problem I see with etcd is maintenance upgrades. Basic operations are difficult enough that when I try to describe it to customers, I don't feel comfortable walking away. So I feel like the etcd operator is huge. And honestly, I trust a CI upgrade procedure that is automated better than I do a human running a playbook by hand, right? I mean, you're going to end up with someone fat fingering something like the AWS outage last year, right? Or this year.
Yeah, so I think, back to Justin's point about having, like, reducing circular dependencies, maybe doing that outside of the Kubernetes API makes more sense for etcd that is a cluster etcd. And if you have, other etcds inside your cluster, right? Like oftentimes if you're running aggregated API servers, you're going to have a second etcd or a third etcd. And for those etcds to be managed by like this sort of standard etcd operator makes a lot of sense, because breaking them is not going to break your cluster, right? But for the cluster etcd, it may be worth building something that doesn't depend on the Kubernetes APIs, which I think is the road that Justin had started walking down. Okay, and then it sounded like Chris had another meeting, so she can't speak to Kubicorn support, but I know that she's been working. She was trying to get it done for our demo as KubeCon. I didn't finish, but working on getting AWS support for the cluster API inside of Kubicorn. Any other thoughts about 2018 plans? I think we will start to sort of refine these over time, but this was
one comment regarding the implementation: should we have something like a example implementation like for Python also, so that it's clearly, because I think all of these are written in Go, so that it's clearly to make clear that you can easily write integrations also with like Python or other tools, because especially Python is quite common in in the ops area.
That's a really interesting idea, because I think, like you said, the point of having the API is that you can implement things differently. So yeah, I wonder how hard it would be to write something in Python. We have actual Python client libraries for Kubernetes now, right? Like real ones.
To what extent are those auto-generated by Swagger?
Maybe this is something that we could use MetaController for.
So let's see. So MetaController, I think you can write in any language. I think Anthony's demos are all in Node in JS, right? In JavaScript.
The primary ones that I remember are JavaScript and Java, or was it .NET, something like that.
Yeah, that would be pretty cool if you could write like a simple machine controller inside the MetaController framework to show how those things kind of play together. Yeah, if anybody is interested in trying that out, even if it's not sort of fully functional, that would be a really cool thing to send a pull request for. But I agree, it would be nice to have an example implementation in a different language. I don't think that's going to sort of be on our critical path and block our path to beta or GA. But I do think it would be nice to have.
Would we want that to live in kubedeploy, I guess?
Yeah, so that brings up an interesting question of what code should live there, or wherever sort of our official repo ends up being. If it's not kubedeploy, we might try to get a top level one that's called cluster API. I'm sort of two minds. On the one hand, I don't want all of the cloud specific code to all be in a single repo. We found with the main Kubernetes repo that doesn't scale very well, especially with Go and Go deps and dependency management. It gets really ugly really fast. We have the GCE code in there right now because that was the fastest way to prototype, but I kind of want to take it out and just have the API definitions and reusable libraries in there and have the cloud-specific code somewhere else. Now what we could do is we could create top-level directories in kubedeploy where one top-level directory is all the shared stuff, and then we have other top-level directories that are sort of like separate repos in the sense that they would build separately, and we could vendor things separately in those repos if we wanted to have a shared code location. But I don't want to get sort of the tangled dependency mess that we have, and we're trying to get out of with the cloud providers in the main repo right now.
Yeah, the mono repo kind of like split project approach sounds like that would be like preferable to dependency entanglement.
Yeah, I mean, right now we have a couple of top-level directories in kubedeploy. Justin's got one for the image builder. I deleted a couple other ones. And then we have cluster API. So we could sort of pull all the GCE code out of cluster API and create a directory that's like GCE machine controller or something. And then have cluster API be vendored into that sort of other directory, even though it's in the same repository, to get sort of a clean separation there. The nice thing about that is that then sort of all the code is co-located, and you're not trying to figure out like, where do I go to find the GCE code or the Amazon code, and like, is it even under the Kubernetes org, or is it under the Google org or the Amazon org or the Azure org? And that might get confusing for users.
Yeah, you would almost need docs in order to link out. And it seems like if something's going to be like an upstream official implementation, it should live in the Kubernetes org.
Yeah, so I think that seems like a reasonable path forward for now. And if we want to extract the code somewhere else later, if they're in separate top-level directories, that makes it really easy to pull out too. So yeah, I think we'll start working on migrating the GCE code out so that the cluster API directory is cloud agnostic. And that should make our path forward a little bit easier too.
So I had another question. The current resources in the cluster API are cluster scoped, right? In a lot of these other projects, they're not, like Kubicorn or the COPS. Is there any thought of making them non-cluster scoped so that they can be used directly? Otherwise, there would have to be some way to translate, right?
Can you be a little more specific? Which resources are you talking about?
Like the cluster resource. It is a cluster scope resource. It cannot live in a namespace. At least right now, right?
So right now we have sort of two resources. There's the machines, right? Which
right.
I don't know that it makes sense to put those in a namespace, since nodes themselves aren't in namespaces. And then the cluster resource really, I mean, it has like 3 properties in it, right? It's got like the network configuration for your cluster, and maybe like 1 or 2 other sort of small things. I guess I'm wondering what advantage it would be to be able to put that inside of a namespace.
So in other projects, you define a cluster resource inside a namespace, but then that cluster gets instantiated somewhere else in a cloud, like AWS or whatever. And it's a completely different entity from where you define the resources, right? And the idea is that you could have multiple defined inside your cluster. If you know, these projects are going to inherit the cluster API in some way, they would need to, I don't know, either we say it's not compatible, or we say, you know, once those, let's say COPS creates a cluster, it will create the necessary resources for the cluster API to manage that created cluster. But COPS itself would not necessarily use the cluster API itself when defining it. Does that make sense? Okay.
Yeah, so I'm just thinking, so when we started talking about the cluster API, one of the things we debated about was whether the API should be single or multi-cluster. And we ended up on the side of single cluster because it makes the auth story a lot simpler, and because the previously Federation SIG, now multi-cluster SIG, is also working on a cluster registry. And it seemed like a nice separation of concerns, where the cluster API deals with, this is sort of my self-describing cluster. And if I want to aggregate across clusters, I go to the cluster registry and I can list clusters. Then the cluster API itself doesn't need to know about how to deal with auth for other clusters. Does that make sense?
Yeah, it makes sense. Okay, so there is no plans at all, at least at the moment, to make this more than one cluster per cluster type of resource, right?
Yeah, so I think your use case is interesting with like being able to have a single place to like talk about clusters that don't live there. So I think we should think about that a little bit. I think Daniel Smith pointed out a similar use case before.
Might this be dealt with? I guess the question is like, what do you want to do with this, right? Like, if the use case is I want to update all my clusters at the same time, right, or something like that, maybe it will be that the multi-cluster registry will have a mode in kubectl where you can apply operations spanning clusters or something like that. So maybe, like, is that what is the sort of, what are you thinking of doing here?
Yeah, having the ability to manage, several clusters at the same time from within a single control plane.
And it might be that at least maybe we'll get that from the multi-cluster registry, the ability to express operations that span clusters. I don't know.
Okay.
Robert, do you know if that's the intention?
For existing clusters, if you have just the single cluster scope for cluster API, if the cluster is standing, you would be able to switch contexts with kubectl. But yeah, I mean, I don't think it's like, it's not that there isn't a plan, but I think that the previous conversation decided that the scope for cluster API would be smaller, and that would be a responsibility that might be better suited for the work that SIG multi-clusters is putting together on this. They did talk about it in their update, in their SIG update at KubeCon as well.
Okay.
Yeah, I think Justin's point is key though. Like, what is the use case we're trying to solve, and is putting multiple cluster definitions inside of a single cluster via the cluster API the right way to solve that? Or since we have the notion of a cluster registry being defined, which is basically the same thing, is that a better place to put it? I don't know that where the path we're going down is the correct path, but we had to pick until we picked that one for now. And if we have good use cases to switch, like it's definitely early enough to switch at this point.
Okay.
Is there considerations that we need to make for our cluster object that would maybe facilitate a consumer of the API that we can kind of talk about right now, like things like names and IDs, or extra properties that you might be able to filter on?
I'm not sure I quite understand what you're asking.
Just, I mean, like with the use case that like something's going to need to aggregate these objects, can we think of anything that we might be missing that would make that an easier task?
Yeah, so we get name as part of the Kubernetes metadata for a cluster, but there's no guarantee those are unique. And I know SIG Service Catalog has the need for a UID. And it's something we've talked about for a while, is how do you assign a UID to a cluster? And so I think that is a field that is needed by the cluster registry. And we may want to figure out how to work that into the cluster API as well. I think you get like a UID from Kubernetes automatically, right, when you create an object. I don't know if that's what the guarantees are on that about being globally unique, though, or theoretically globally unique, right?
It is a UID, so I think it will be in practice unique. I think the one thing from the experience of COPS is that it's nice to have like the DNS name or whatever it is to know how to get it, but I don't know that, or the IP address of the API server, the API ingress point, I don't know that necessarily that is a cluster object, because in order to get the cluster object, you must have reached it anyway. But it is annoying sometimes to, like, even when you're inside the cluster, to not know the external ingress point. But I don't know that that necessarily belongs in the cluster API, and we can certainly add it later if we need it. Like, I can't think why we would necessarily require it for anything we're doing here, although I've often come across, places where I would want it.
I think having a UID is pretty important. We found pretty early on in GKE that you want to have a unique way to address a cluster, right? Especially if a user can reuse the same name over and over, and you want to know that this is a different cluster than the one they created last week with the same name. And so we assign UIDs to each cluster so that we know, when we're searching through logs or something, which cluster we're talking about. And I think even within like the cluster API, if you are trying to manage these clusters through the cluster API, having that uniqueness is going to be really important. Okay, so I want to move forward because we only have 15 minutes left. Sebastian, since you're on the call, I added an agenda item to get an update from you about MachineSets. Last week you said you guys would try to send a PR for MachineSets. I know it's the holidays and that may slip, but I was curious what the status of that was.
Yeah, we have some first implementation, or we're working on. It's currently not ready to push. I guess we get it next week. Probably we don't have a call. No, next week is Christmas. So after the holidays, and yeah, because I also forgot Henrik is already on vacation, so he had time this week. So I guess after the vacation we can do the first commit.
Excellent. Yeah, I was assuming it was something along those lines, since this is the time of year when people all disappear. But I wanted to check in and make sure we were still on the path and making forward progress there.
Yeah, Justin, I saw your comment. Yeah, we will try for Christmas. So.
All right. So next is a question about status of AWS implementation. David, I don't know if you were looking for status or if you had status to provide.
I was looking for status. I mean, I haven't reviewed all of the previous meeting notes yet, but I started. I guess maybe a question just for Justin is, have you guys started the COPS implementation? And do you know when you might start it? Are you going to reuse Kubernetes code? Since Chris isn't here to comment, I don't know if we can answer it.
We've not started anything in COPS yet. I think our initial plan was basically to just do the minimal bridge, as it were. So we'll look at what KubeCoin has, that we have a lot of similar code already, and it will probably be harder to adopt, in COPS adopt it, but not really anything out. But if anyone wants to help, please, PRs are always welcome, but otherwise, we'll see how quiet Christmas is.
Okay, I think that answers my question.
I have a question about that, Justin. Since we are defining an alpha API at this point, and so we're not promising any sort of compatibility, how do you anticipate COPS adopting that before we define the API as being stable? Are you guys going to sort of offer that as an additional way to define machines in addition to what you have currently for instance groups and translate between the two, knowing that sort of like your internal representation can remain stable and you can just change the mapping if we break our API? Or do you have some other way you're thinking about doing it?
Exactly. We'll do a feature flag, or that the instance group itself will have a field which enables you to define like whether you want to map it in the existing legacy way to an AWS scaling group, or whether you want to map it to a machine set, for example, maybe. But some sort of opt-in behavior at the feature flag or field.
Yeah, because I certainly don't want to break COPS users, but it would be great to start getting more mileage on the API to sort of prove it out and see if we need to change it. Because I think one of the problems in Kubernetes in general is people define alpha APIs. They're disabled by default. A lot of people don't turn them on. They don't get a lot of mileage. They graduate to beta, and then people find problems with them. But at that point, they're beta, and we are promising compatibility. So if there are any ways that we can sort of encourage use of the APIs when they're in alpha, and I think that's one of the reasons that we want to move our end-to-end tests over from Kubernetes Anywhere, is that will sort of stress the cluster API in various ways as we try to configure different types of clusters for different types of end-to-end tests. But any other sort of more real-world use that we can get would be awesome.
Well, I'll think about whether we can even go the whole way and get some ED tests that way, maybe. Like, do it for masters as well, but that is going to be harder.
Sure, and I know that Sebastian has been talking about only doing it on nodes on their side as well. So I don't think that that's a crazy way to either.
Right, but it'd be good to get, as you say, it'd be good to get more coverage. But yes, it'll be harder for COPS at least to do. Like if you're starting from scratch, maybe easier.
Right, and I think Kubicorn has that advantage of they don't have a stable release yet, and so they can just break all of their code at will at this point. And Chris was very excited about that. She's like, I don't have to promise any support to users. So I think it'll be easier for them to rejigger their code to adopt probably a little bit faster than you guys.
Sounds like the race is on.
That's right. All right. Are there any other agenda items? As someone mentioned, there's no meeting next week. So the next meeting is 2 weeks from today at the same time as today. So remember, we moved an hour earlier. Hopefully nobody's going to show up in 10 minutes hoping to dial into this call. If folks don't have any other agenda items, we can get 10 minutes back and have a nice holiday break. Going once, going twice. All right. Thanks everyone for joining. We'll see you in a couple weeks.
Merry Christmas.
Merry Christmas. Happy Hanukkah. Happy Kwanzaa.